The James Webb Space Telescope has made a groundbreaking discovery suggesting the existence of another universe beyond our own. Recent data from the telescope, focused on the deepest parts of the early universe, hints that our universe may have merged with another universe in its early stages. Scientists have identified ancient galaxies in the distant early universe that defy our current theories. This new evidence suggests that the early universe we are observing is fundamentally different from the universe we know today. The excitement among the scientists was palpable. They designed the telescope to see the very first galaxies that emerged in the universe, and the results in just 12 hours exceeded their expectations. New images from the James Webb Telescope are providing a glimpse of what our universe looked like over 13 billion years ago, and it's not what they expected. These observations are changing everything, giving scientists an unprecedented view of the early universe and uncovering phenomena that have left astronomers in awe. The universe has always intrigued us with its vastness, prompting questions about whether it has an edge or boundary or if it stretches on infinitely. Observations with powerful telescopes have indicated that our universe began about 13.8 billion years ago. Using this information, scientists developed a standard cosmic model to explain how the universe has evolved over time. However, recent observations from the James Webb Space Telescope have challenged these long-standing theories. The telescope's ability to peer deeper into the early universe than ever before has captured data suggesting that our understanding may need to be revised. Traditionally, we've believed that the universe had a definite beginning and has been expanding since. Now, some scientists are considering the possibility that the universe might not have had a beginning in the conventional sense, or that the early universe was vastly different from what we know today. At the recent 2024 International Space Science Institute Breakthrough Workshop in Bern, Switzerland, a group of scientists summarized some of the Webb telescope's results so far. Their work, published in a new paper titled "The First Billion Years According to James Webb Telescope," highlights that scientists have been carefully studying the first billion years after the Big Bang. During this period, galaxies were in their infancy, stars were forming, and black holes were becoming more massive. To see the first galaxies, the most powerful telescopes are required. The Hubble Space Telescope was limited to observations up to a redshift of 11, but the Webb telescope has pushed that limit to the edge, with high redshift observations reaching down to Z equals 14.32, corresponding to just 300 million years after the Big Bang. Additionally, astronomers have detected carbon in a galaxy observed only 350 million years after the Big Bang, suggesting that the conditions for life were present almost from the dawn of time. The presence of oxygen so early in the life of this galaxy is surprising and indicates that multiple generations of very massive stars had already lived and died before we observed the galaxy. These observations together reveal that JADE's GSZ14 is not like the types of galaxies predicted by theoretical models and computer simulations to exist in the very early universe. With all this data, scientists now believe that the James Webb Telescope will soon observe galaxies from when the universe was very young, at a redshift of 20, looking back to when the universe was just a few 100 million years old. However, they are concerned that if the telescope finds even more distant galaxies, it could challenge our understanding of how galaxies form. According to our standard cosmological model, there is a limit beyond which we cannot see anything, known as the Dark Age. Following the Big Bang, the universe entered a period known as the Dark Ages. During this time, the universe was filled with neutral hydrogen gas, and there were no stars or galaxies to emit light, making it a dark period in the universe's history. These new discoveries by the James Webb Space Telescope suggest that our early universe might have been influenced by the merging with another universe, leading to the formation of galaxies that defy current theoretical models. This evidence points to a more complex and dynamic early universe than previously thought, raising questions about the fundamental nature of the universe itself. The presence of ancient, massive galaxies, the detection of carbon and oxygen in the early universe, and the possibility of observing galaxies from the universe's earliest times all suggest that we may need to revise our understanding of cosmic evolution. These revelations have profound implications for cosmology. They suggest that our universe's history may be intertwined with other universes, challenging the notion of a singular beginning and expanding our understanding of cosmic evolution. The potential merging of universes could explain the rapid formation of galaxies and the presence of elements necessary for life so early in the universe's history. This merging could also account for the variations in the universe's expansion rate and the non-uniform distribution of matter, further complicating the standard cosmological model. In summary, the James Webb Space Telescope's discoveries are reshaping our understanding of the cosmos. They suggest that the early universe was more complex and dynamic than previously thought, possibly influenced by interactions with other universes. These findings challenge our current cosmological models and open up new avenues for understanding the universe's origins and evolution. As we continue to explore the early universe with the James Webb Space Telescope, we can expect to uncover more surprises that will deepen our knowledge and potentially revolutionize our understanding of the cosmos. The James Webb Space Telescope has unveiled a groundbreaking discovery that is challenging our understanding of the universe's early days. Recent images from the telescope have revealed galaxies that existed even before what we traditionally call the dark ages of the universe. This period, characterized by its opacity and darkness, has long been a mystery, with much of what we believe about it based on theory. The discovery of these ancient galaxies is baffling scientists because it's unclear how they could have formed so early. What's even more puzzling is that these ancient galaxies look nothing like those we see from the early universe, raising profound questions about whether we might be looking at an entirely different universe. One of the key questions arising from these observations is why we keep finding giant and mature galaxies as we look deeper into the universe. According to our current understanding of physics, we should see small and young galaxies when peering into the early universe, and there should be no galaxies or stars beyond a certain distance. However, the Webb telescope has found more and more massive galaxies, suggesting we might be observing a universe with different laws of physics. It's not just the presence of massive and bright galaxies that challenge our theories. Recent research has introduced a surprising twist in our understanding of the early universe. The fundamental laws of physics, which work so well for the nearby universe, might have been slightly different back then. A study published in the Journal of Cosmology and Astroparticle Physics suggests that gravity may have been about 1% weaker on very large scales in the early universe. This discovery emerged from analyzing data from the cosmic microwave background, CMB, the faint glow of radiation left over from the Big Bang. The CMB is crucial for understanding the universe's infancy, including how the first galaxies formed and what happened right after the Big Bang. Researchers found that their model did not match the actual observations of the distant universe. However, when they adjusted Einstein's theory to account for a 1% weaker gravity, their model aligned more closely with the observed data. This small adjustment indicates that Einstein's theory might need some rethinking regarding the early universe. Another significant problem in cosmology is that the latest observations from the James Webb Telescope show the universe is not expanding uniformly everywhere. Different methods of measurement have yielded different values for the rate of the universe's expansion. Astronomers have confirmed that all these methods are accurate, with no errors in measurement. This discrepancy suggests that the universe is expanding differently in different places and that the cosmological constant known as dark energy, responsible for the expansion, is not actually a constant. Instead, it has different values in different places in the universe. These discoveries suggest that the deeper we look into the early universe, the more our theories fail to hold up. Several theories have been proposed to explain this asymmetry, one of which is the idea that our universe collided with another when it ballooned out to an incredible size at a fantastic speed. In the multiverse hypothesis, our universe could have popped into existence near another universe. When it expanded, it may have run into the neighboring universe, potentially explaining why the laws of physics aren't uniform across the universe. This theory suggests that the southern portion of the universe is bound by a different set of physical laws than the northern side. This idea could also explain the existence of strange and massive galaxies only a few million years after the Big Bang and why the universe is different in different directions. The discrepancy between our theories and observations in the early universe is revealing many hidden mysteries. New images from the James Webb Telescope are bringing forth new possible explanations about the existence of our universe. These observations suggest that either we are missing something significant in our current understanding of the universe or that the early universe is beyond our comprehension. In conclusion, the latest discoveries from the James Webb Space Telescope are revolutionizing our understanding of the universe. The finding of ancient galaxies that existed before the Dark Ages challenges our current theories and suggests that the early universe might have been influenced by different physical laws or interactions with other universes. The possibility that gravity was slightly weaker in the early universe and that the universe is expanding at different rates in different places are just a few of the revelations that are reshaping cosmology. These discoveries highlight the need for new theories and models to explain the complexities of the early universe. Thank you for engaging with these fascinating discoveries. Please share your thoughts about these recent revelations in the comments.